Thank you. Perfect. So, as introduced, my name is Leo Howden. I'm Managing Director of Descycle. Today I'm going to be talking about how we're empowering sustainability and facilitating the path to net zero in the metals industry. So I'd like to start off with what is universally known as an uncomfortable truth, and it's this. The metals industry that we rely on is powered by carbon-intensive and pollutive extractive and recycling processes. And simply at Descycle, we don't believe that needs to be the case. In fact, we're actually committed to transforming these processes through innovative technology. So when I say that it's carbon-intensive, pollutive process, that's actually what's powering our next generation. So you can see, we start, we mine, we extract, that releases CO2. It uses toxic chemicals, heavy acids, lots of water, lots of raw materials. We move that into a process of extraction. That produces CO2 and emissions, and we use high temperatures and lots of power. And at the end, we get our shiny electric vehicle. Our vision is to change this and develop disruptive but sustainable alternatives, replacing what is the highly toxic and pollutive carbon process that we're currently using in the metals industry. So what's needed? If we're going to disrupt something, we have to change something. And if we're going to change something, we have to make something completely new. So the reality is, if we want to do this, we need something that is large scale, low cost, and environmentally friendly. And this led to the development of a new class of chemistry called deep eutectic solvents. Deep eutectic solvents, or DES as they're known, is a platform chemistry. It has unique properties, and these unique properties allow metals to behave completely differently in DES than they would in any other processing technology. And this is what makes DES fundamentally different. They're organic, biodegradable solvents. They are reusable, they are scalable, and they are tailorable to individual metals. So what does that mean? Well, it means that DES's tailorability has the potential for a wide range of applications, and effectively offers a very true, sustainable economic way of recovering metals environmentally. They're low energy, low water, low temperature, low CO2, and no emissions. So what we have is a really sustainable way of replacing the current toxic processes that we're using to recover our metals. And we're using deep eutectic solvents to solve a real-world problem. And that problem is electronic waste. It's this. Everybody's familiar with this. Mountains of rubbish that don't get recycled. In fact, electronic waste is the world's fastest growing waste stream. Almost 54 million tons of electronic waste is produced every single year, equivalent to 7.5 kilos per person. But that asterisk, the UK is 3 times as much, almost 24 kilos. It's a very valuable waste stream, $57 billion a year, based on 2020 numbers, of material that is used every year that is effectively discarded, with only less than 20% collected for recycling. It literally is a gold mine in your pocket. So what does the market size look like? Well, it's very big. In 2022, the value of the contained metal in electronic waste that's produced every year is around $65 billion. By 2030, that is looking at $82 billion, a huge annual compound growth rate. So interestingly, though, 60% of the actual value is contained in only 5% of the waste. And our target feedstock is to process that waste and put that metal back into society in a sustainable way. So we're targeting small domestic appliance printed circuit boards, high-value e-scrap, which has a global market of about 15 billion a year, which will soon be 28 billion. How are we going to do this? How are we going to change this industry? Well, we're actually going to disrupt through integration. So what does it look like currently? Standard process. Upstream recyclers or original equipment manufacturers, they collect the e-waste. Then they disassemble it into its component parts. Then it goes to the downstream recyclers. It's shipped, which creates CO2. It's shredded. Then it's put into a big roasting smelting, which produces CO2. Then it goes and has more refineries, which produce additional CO2 and metal particulates, and then we recover our metals. And it's this part of the system, which is highlighted, that we are looking to provide an alternative to. So what does the Descycle process look like? Well, it's substantially simpler. We integrate with the upstream recyclers before it goes to the downstream recyclers, which means this is the same process, but then it's one step to the recycling. And this process is materially cheaper to construct than to construct a big smelter where you need to aggregate all of that material. And what that means is zero particulate emissions, zero carbon emissions, and no transportation of hazardous waste. So our business model, this integration business model, offers a lot of alternative, unique features that will allow adoption in the industry. So by integrating with these manufacturers, the guys who actually collect the electronic waste, it allows us to process that locally, which means that the footprint of our plants is materially lower. We don't need to aggregate and have very large buildings and processes and land to do what we're doing. It also means that we can create joint ventures where we can share the profit, make a win-win situation. The people recycling the material, recycle it on site, get better payability, and also it's a more sustainable process. And from this, we can scale into multiple joint ventures. So we have our first joint venture in the UK with a group called GAP. They're based up in the north of England. And we're looking to put in place a 5,000 ton a year recycling plant that has superior economics and materially reduced capital expenditure. We're also in active discussions in many other markets to scale up the business model. So how are we actually going through our scale-up process? Well, we're using a development partner, the Centre for Process Innovation. We're leveraging the UK's best-in-class ability to scale up processes using the catapult system that we have in the UK. CPI, if you don't know, are part of the high-value manufacturing catapult system, and they are one of the foremost groups in the UK for scaling up technologies. They have over 550 scientists and engineers, and they have over hundreds of millions of pounds invested in them and thousands of companies and projects that they've worked on. We have 10 full-time scientists, engineers, and chemists working on our facility or our process at CPI, which allows us to quickly scale up. So it looks like this. We're currently at the feasibility and lab stage. We'll be moving into the Series A round in January or February of early next year, which will be funding a pilot and feed engineering design for a commercial plant, which will co-locate on the GAPS facility in Newcastle. So a bit of a word on our team. Who are the people who are actually helping to push this forward? Well, we have the scientists. We have our Chief Technology Officer, who has been working on deep eutectic solvents since its inception at the University of Leicester in 2024. We have a commercial team that has a background in the metals industry and also in fundraising. And we have a group of advisors who are able to connect us into the industry and provide that additional support. So some recent milestones. We've just closed a 4.85 million funding round where we were supported by a number of large groups in the UK who are well known in this area, including groups such as Green Angel Syndicate, Kiro Development Partners, TSP, and CPI, who also invested in the round. We've actually been awarded a £1 million grant from the UKRI, which is part of the Future Leaders Fellowship for our CTO. And we've also recently become part of Amazon's Sustainability Accelerator, where out of 1,500 applications, 16 companies were selected to be championed by Amazon for sustainability. And what that means is we get to work within the Amazon ecosystem and with the UK charity WRAP to really accelerate our plans and commercialization. So some final thoughts. If you were to mine 1 ounce of gold in a traditional process, you would emit over a ton of CO2. That's equivalent of going from London to Mumbai and back on an economy class ticket. There has to be a better way of getting this metal into industry at a lower cost to the environment. With Descycle, That's 57 kilos, equivalent of London to Manchester and back. That's the difference with using our technology. It's safer, biodegradable and recyclable. There's no burning, no smelting, no harsh treatment of acids, which leads to low CO2 impact. It's also smaller and simpler, which means adoption is easier. And if you have any questions, I'll be happy to answer them at booth G10. Thank you.
Thank you, Leo. Has anyone got any questions? I'll start then. What industry do you see being the biggest kind of user for your products? What industry will find the biggest application for this technology?
Well, I think there's many industries that can benefit from what we're doing. As we said, it's a platform chemistry, which means it's widely applicable. We're focusing on electronic waste recycling. That's our lowest hanging fruit. That's our go-to-market strategy. As we said, we're integrating with the collectors, the groups who actually pick up and dismantle the electronic waste. They can be small groups, private groups, or large groups. So groups like Veolia, Biffa, those types of groups would have an interest in what we're doing. But outside of electronic waste, the applications are enormous. We're already talking to many mining companies who are looking at ways to reduce their scope 1, 2, and 3 emissions. And we're partnering with some of those groups to trial our technology directly at their site to go upstream and actually look at putting the process into the mining industry itself.
Any more questions? Do you think, so this could be an all-encompassing question, but so do you think that, and the answer to my question is yes, but do you think that we should improve the circularity regulation and like obviously regulation around recycling metals and so on? We're seeing kind of things like that emerging from the EU. Do you think that we should be legislating that in the UK as well?
It's a good question. I think adoption really gets driven by economics. I think legislation supports that, and we see that with the e-waste WE directive, which is really focusing on the collection. But adoption can only be driven by actually showing that something is economically viable and an alternative that can actually be delivered to customers. We don't want to change what people are doing. We want to integrate with them so that they feel that they're just amending the process to be more sustainable, but economically viable at the same time.
Thank you very much.
Great. Thank you.